All right, this multiple choice section continued, starting at number 84. We want to find f prime of 0 if f of x is g of x. So the derivative of this composite function, we have to use the chain rule. It's going to be g prime of g of x times g prime of x. And so f prime of 0 is g prime of g of 0 times g prime of 0, just replacing those x's with zeros. And all this information we should be able to get from this graph. So g of 0, this is a graph of g. G of 0 is 3 times g prime of 0. So g prime of 3, that would be the slope here. It looks like the slope of this line is at negative 1. Looks like it's going from the point, yeah, it looks like that slope is negative 1, right? I'm just doing the rise over run of this. Goes down 5 over 5. And then g prime of 0, that looks like it has a slope of positive 2. So there you go. That's a sneaky little chain rule problem. Number 85, let f be a function such that f of negative x is equal to negative x. I don't know if you remember from, Algebra 2, when do you see this for the first time? Pre-calculus? This is the definition of an odd function. It's one of the ways of describing an odd function. If every single time you do like f of negative x, it's the upside down of f of x, right? It means every time you go over here, then if you go the other way, it's down here. That's what forces a function to be odd. So that we need to, I suspect we're going to need to use that information. So the area from 0 to 2 is 5. I'm just going to use my little sketch here, which means that here it would be negative 5 because it's an odd function. Then if you did the area from negative 2 to 2 of f of x plus 6. Okay, so the plus 6 part, we can split this up because you're allowed to do that. I mean, we effectively do that every single time we evaluate an integral. And this from negative 2 to 2, because it's an odd function, that's just 0. So this is just like a 4 by 6 rectangle after that stuff cancels out. Right, you can actually do the calculus if you want, but I'm thinking geometrically, so from negative 2 to 2, it's 6 high, it's just a rectangle. All right. Looks like quick scan of answers. Looks like I'm going to have my calculator on here. Let R be the region in the first quadrant bounded by the graphs of 4 cosine pi over 4. That looks like this. And then this parabola here. So that's this one. The region R is the base of a solid. For the solid, each cross-section perpendicular to the x-axis, so we're slicing across this way, is an isosceles right triangle. You know, do you know what an isosceles right triangle is? It is half a square. That's a good thing to know. And this side of the square here, that's the leg in the triangle. So that is, I'm going to call this F, and I'm going to call this G, F minus G. So the area here of this half a square is F minus G squared over 2. Don't want to square the 2. Dx. And I'm going from 0 to 2. So that's the expression I need to enter into my calculator. Make sure I'm in radian mode. Haven't used this calculator yet today. So mode radian. Good. And I guess I'll put the 1/2 on the outside. It doesn't really matter. and then I'm going to do math 9, and I'm going to go from 0 to 2. And then inside here, I want my f function, that's 4 cosine. I put an extra set of parentheses because I'm going to have to square that whole thing. 4 cosine pi x over 4, that looks good, minus x minus 2 squared, close parentheses, and then that whole thing squared dx. Got to be very careful entering everything. Oh, that gives us answer choice A. There's the one where you forgot to cut it in half. Okay, 87. No calculator here. Suppose that the limit as n approaches infinity of a sub n is equal to infinity. So that's a very divergent series. The terms are actually going to infinity. And the a sub n plus 1 is greater than a sub n. So all the terms are positive and they keep getting bigger is what this means. If you take any term, the next term is always bigger than it. So the terms are just increasing forever. Which of the following statements must be true? Is it true that 1 over a sub n diverges? I don't think so. That certainly doesn't have to be true because we could make a series of this type. You know, we could make a p series where the p is 2. That would be this series, right? We know that that converges, and that follows the rule of those numbers, a sub n getting bigger. So that definitely could be false. We could have a convergent series of that type. How about an alternating series with just the a sub n? Well, if you have one, I'm just going to use that as an example again. 1 minus 4 plus 9. If these keep getting bigger and bigger, that can't converge if they're going to infinity. The alternating series thing is that guarantees convergence if your terms are going to 0. So that's not true. So how about 1 over a sub n? Does that have to converge? It doesn't have to be true because it could be the harmonic series, right? That series satisfies the 1, 2, 3, 4. That satisfies all this stuff. Terms are going to infinity. They keep getting bigger, but this diverges. So that doesn't have to be true. But if they alternate, then it has to be true. So it's D. A little tricky. Gotta make sure your brain is turned on all the way, turned up to 11. At time t greater than or equal to 0, a particle moving in the xy plane has a velocity vector given by 3, so that's the x component, constant velocity, and then this y component of the velocity is that. If the particle is at the point 1, 1/2 at time t0, how far is the particle from the origin at time 1? Okay, so what I need to do is figure out what is the x position at time 1. And to do that, I'm going to do fundamental theorem of calculus to find out from 0 to 1, because I know that that's the position at 1 minus the position at 0. And I know the position at 0. It's there. So x1 is equal to, this is just a 1 by 3 rectangle, right? So that's 3 plus 1. And then for the y coordinate, I'm going to go from 0 to 1, 2 minus t squared dt. That's going to be equal to the y position at 1 minus the y position at 0, which is 1/2. So I need to find this with my calculator and then add 1/2. negative t squared, is that what it is? So that should be my y position, 1.310. And then how far is it from the origin? Well, if this is its position, 4 comma 1.310, then its distance from the origin is the Pythagorized distance, hypotenuse. So that would be 4 squared plus 1.310 squared, and that's about 4.209. I betcha they have an answer there for the person who forgot to add those initial values there. But I'll let you go back and check that if you like. All right, 89. Let f be a function, f of 0, f prime of f of 0 is 1, f prime of 0 is 2, and f double prime of 0 is negative 2. Which of the following could be the graph of the second degree Taylor polynomial? Well, I mean, this is telling us some information about that, right? This is telling us that it goes through the point 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. So that's a check for all of them on f of the f information that we know. And then f prime of 0 is 2, so that's the slope at 0 would be 2. Then that doesn't look like a slope of 2 to me, not based on this scaling here. Well, oh, maybe it is because of that scaling. Maybe that goes up to 3 because of the way it's kind of spread out. So that could be. Not going to cross it out. Here, this slope that looks like it could be also. And here, no. Well, I think the slope looks okay. Yeah, sorry, I'm looking ahead to the concavity. And then this looks like also it could. So it looks like they all might have possibly the right slope. This is the one that looks like it has the right concavity of negative 2. So no, because the concavity here would be 0. This, the concavity doesn't look like it's negative enough, and this, the concavity is positive. So I would want to convince myself here that between these two, which one could be right. And let me look at the slope of this again. 1. So maybe this one's not steep enough. Maybe this one fails on the slope test. It's a little too shallow there, and this one's steeper. It looks like it makes it. I think that's what we're supposed to be looking at here, that this one only has a slope of about 1. So anyway, that's what we're supposed to be looking at. Does it go through the right point? Does it have the right slope? And does it have the right concavity? And I think this is actually the one that makes it, because it's concave down, it's got a slope of 2, which we had to look at very carefully because of this kind of funky scaling here. So B is the correct answer for that one. And the last one. So series sum from n equals 1 to infinity of this converges to S. Based on the alternating series error bound, what is the least number of terms in the series that must be summed to guarantee a partial sum? Partial sum is just S sub n, that is within 0.03 of S. Okay, well, I know the alternating series error bound says S, the difference between the actual sum and the nth partial sum is less than a sub n plus 1 absolute value of. So if you want to guarantee that you are within 0.03, then you got to find a term, this n plus 1 term, such that that is true. Okay, so let's just set this up and do exactly that. Because I'm doing absolute value, I don't need the sign flipper, so I'm going to just take 1 over the square root of n plus 1. Less than or equal to 0.03. I can do 3 over 100. I guess you could do that if you want. And then I'm going to flip both of these over. When you flip over positive numbers in an inequality relationship like that, like 2 is less than 3, but 1/2 is greater than 1/3, the sign flips over. So that means that n plus 1 must be greater than or equal to 100 over 3. I'm going to square both sides, so n plus 1 is greater than or equal to 33 and third. I'll just do the whole thing there. 100 over 3 squared. And then I'm going to subtract 1. So n has got to be greater than or equal to, now n's a whole number, so I'm just going to add that. It's got to be greater than or equal to that. And, well, n's changed. So if n's got to be a whole number, it would have to be, that would be the smallest one right there, would be c. That wasn't so bad.